Magnets. We see them everywhere. On our fridge, in our electronics, even in nature. But how do they work? In just a few minutes, we'll break down the basics of magnetism and explain what makes magnets so unique. At the heart of every magnet is something called a magnetic field. This field is an invisible force that surrounds the magnet and creates attraction and repulsion. Every magnet has two poles, a north pole and a south pole. The magnetic field lines move from the North Pole to the South Pole, creating an area of influence around the magnet. Here's a simple rule. Opposites attract and likes repel. If you bring the North Pole of one magnet near the South Pole of another, they'll pull together. But if you try to push two North Poles or two South Poles together, they'll repel each other. This happens because of the way the magnetic fields interact. When opposite poles are near each other, the fields merge. But when like poles face each other, the fields push away. Not every material can be attracted to a magnet. For a material to be magnetic, it needs certain metals like iron, nickel, or cobalt. But why these metals? It comes down to the arrangement of electrons. In atoms, electrons spin and orbit the nucleus, and each spinning electron creates a tiny magnetic field. In most materials, these magnetic fields cancel each other out because the electrons are paired up and spin in opposite directions. But in magnetic materials, many electrons align in the same direction. This creates regions called magnetic domains, where the magnetic fields of many atoms combine to produce a stronger field. When these domains align with an external magnetic field, like a nearby magnet, the material becomes magnetized and is drawn toward the magnet. Magnets aren't just naturally occurring. We can make magnets using electricity. When electric current flows through a wire, it creates a magnetic field around it. Wrap that wire around a piece of metal like iron, and you get an electromagnet. The best part? You can turn it on or off by controlling the flow of electricity. Electromagnets are used in countless devices, from speakers to MRI machines. Magnets may seem like magic, but they're actually the result of predictable scientific forces. From the small magnets in our electronics to the Earth's magnetic field guiding us, they play a role in our everyday lives in ways we rarely see. And that's the beauty of science. Even the simplest forces can have incredible impacts.